Okay, so today we're going to get into a brief introduction to Linux, and we're also going to show you guys tips to get a proper VM set up. I know it can be pretty redundant for those of you who have some minor experience with command line in Linux, and for those of you who could possibly have a VM already set up on your personal machines. But we like to start with a fresh slate. We like to make sure everyone's on the same page, and everyone knows exactly where to start from this point forward, because as we get into a lot of the other meetings, it'll be more advanced than just simple command line sort of activities and stuff like that. We'll get into reverse engineering, we'll get into binary exploitation, some crypto and stuff like that. So we want to make sure you guys have this foundation in order to move on to the next meetings. So getting started, if you guys hopefully brought your personal computers, we're going to install Kali on VirtualBox. I know last meeting we mentioned that there is a VMware license for UFCIC students. If you didn't see the form that I sent out last week, I was collecting UFL emails and UF IDs in order to be put on the list of people to get licenses. And for those of you that did submit the form, we'll be getting information to you in the coming weeks. But if you are interested but didn't get the chance to send out the form, watch out for the second round of the form. I'm going to be collecting more UFIDs and more emails just until we have our licenses sort of run out. So keep a lookout for that. But for now, we're going to be using VirtualBox because it's a great free software to get just a basic Kali instance running. Some disclaimers: if you're using Windows, this tutorial will be favored to you. Because a lot of the tutorials are Windows-based, but it's totally doable on Mac and other operating systems. But another disclaimer is that your machine must have at least 8 GB of RAM. Of course, more is favorable, but if you don't want it to move like 3 pixels per second, at least 8 GB of RAM is required. And we also recommend having 40 GB of free disk space, just so that you're basically running a second computer on your computer. So we want to make sure that that computer has enough gigabytes for it to run smoothly as well. So moving forward, if you guys didn't see, I sent all the links that'll be in this presentation in the general channel of the UFSIT. So if you can't type in these links, I sent them in Discord. But first, you're going to want to download the Kali Linux ISO, and you want to make sure that you know where this is downloaded, because finding the ISO file can be pretty stressful. Sometimes I downloaded like 5 of them, but I didn't realize where it was going. So make sure you download Kali Linux. And once you get onto your page, make sure that you're clicking the area that says virtual machines. You don't want to do bare metal. You want to make sure it says virtual machines. And me personally, my machine is a 64-bit operating system. If yours is 32-bit, of course, choose 32-bit, but make sure you download that part. And once you have that, make sure you have VirtualBox and its extension pack downloaded. So if you're not on Windows, this website has an option for you to click the Mac distribution, but download the package for your operating system and make sure it's downloaded. So once all of those are downloaded, I think it might take a little bit to make sure that it's completely downloaded, the executable for installation is set up and stuff like that. But now that you have exactly what to download, how to download it, this is a really great tutorial for following step-by-step on how to set your RAM, how to set your disk space, how to set pretty much everything that you need for Kali with your ISO. I'm not going to go deep into it because recreating the wheel can get kind of tiring. But I used this tutorial to set up my own Kali Linux a few years ago. So as we run it through the rest of this presentation, if you want to be setting that up so that you'll be able to complete the exercises at the end of this presentation, that'll be great. So moving on, while everything's downloading, or if you're just taking tabs for downloading it on your home PC, let's get into what is Linux. Linux is any other operating system. I know a lot of you are using Windows. This lab has Windows. A few of you are on Mac OS, and basically Linux is another operating system. More specifically, Linux is the kernel component of the Linux and GNU operating system. GNU allows you to actually use apps with a GUI, so opening browsers, opening different applications, because Linux itself is just the kernel. You really don't have a graphical interface. That's why you always see people using just black box terminals, because the GNU is the actual like part, like when Windows starts up and you see the homepage and you see like your wallpaper and stuff like that, that's what the GNU is. So moving forward, what is the command line? The command line interface is a text-based interface for running applications and basically using your computer. Back then, it was the original way to use a computer because there wasn't any delay for having the graphical interface of applications to load. You didn't have to wait for the browser to buffer and stuff like that. It was just using the command line, using everything that's in the computer with an executable, and just traversing the file system and stuff like that. Command line is also referred to as a terminal. That'll just pretty much be interchangeable. And the way you use the command line is through commands and arguments. Right here, you can see the LA command has the arguments tac A and tac L, or you could use them combined with tac AL. Moving on to the basics. With a lot of these CTF challenges, blue team challenges, red team challenges, you're going to really need to be familiar with the file system. You're going to be familiar with the majority of these commands, if not more. The most pretty basic command is pwd, which is quite literally print working directory, your present working directory. If you're ever confused on, oh wait, where am I? How did I get here? If you do pwd, it'll print your exact file location in the file system. Next, once you're somewhere, you're going to actually want to find out what is inside of the directory that you're in. So you're going to want to use ls, which lists the contents of your pwd. After that, if you want to get out of there, if you want to change to somewhere else, you're going to want to use cd with the specific path. And we'll go more into the basics of how to use cd later. But cd is also quite literally change directories. As you're going to notice, a lot of these commands are abbreviations of their full functionality. And sometimes if you don't know a command, but you can kind of guess what it says phonetically, then you're almost always on the right track. Next, when you want to just create a file without having a text editor, because of course, like I said, Linux is just the kernel component. A lot of times you're not going to have like a graphical interface for a text editor. You're going to want to use touch and then specify a file name. This will just create a file name without opening it. It'll just make sure it's present in the file system. Next up will be, instead of making a file, you want to make a directory. So make dir mkdir with the directory name will create a directory. Other times you're going to want to move files. You're going to want to change the file names. Then you'll be using the mv command and make sure that the ordering of your file names is correct. Because sometimes if you mix them up, you're going to move something somewhere and you're not going to know where you moved it, or you're not going to know which file moved where. So make sure that following the mv command, you have your original file and then you have your new file if you want to rename it, or your original location and your new location. And after that, following renaming, changing files, a lot of the Linux command line is manipulating files, their permissions, their extensions, stuff like that. So if you want to change file permissions, you're going to use chmod with the mode and the file name. And that just basically changes your file permissions. Moving on to how do files, directories, and permissions work. Directories have files, and they can also have other directories within them, sort of like a hierarchy in many cases. Permissions can be set for all file owners, groups, and all of the users. So sort of like on Windows, you can lock a file to only the owner viewing it. You can lock a file to all different groups using it, or a file can be public to anybody who's on the system. So below you see some examples of what you'll see if you list the contents of a directory. The first one is what it will look like if you had just a regular file in the file system. First, you'll see that the first little tac means that it's a file. You can't traverse it. The just blank tac is specifically for a file. Then you're going to have the group of owner permissions, which is the first 3 characters. After that, you'll have the group of group permissions, and then you'll have the group of permissions for all other users. So for the first file, you'll see that the owner can read and write to file 1, but all other groups can only read it, and everybody else on the system can only read it. Then you'll see that Colonel Sanders is the owner. I think, yeah, the Colonel Sanders is the owner and student is the group. So Colonel Sanders owns his file and it's in the student group. Below, you'll see that there's a directory, but because there's a D at the front of it, that specifies that it's a directory. So any directory, you can go inside it if you have the right permissions. So you'll see here that the owner can read and write to the directory, but only groups can read in the directory. And most times, if you can't write to the directory and you can only read it, you can pretty much sort of guess what's in it, because if you can't write to a directory, a lot of times you don't want to see what's in the directory. And below it, you'll see putting into work another permission that we haven't seen yet for executable files. This Python file has the X character enabled on it because you're able to execute that file as an owner, meaning you can run that Python script if you own it, but everybody else can only look at it. So following all of these, like I mentioned before, you want to find out, how do you use CD? What are directories? What are the different names? How do you get between them? A single dot represents the current directory that you're in. Double dot means your parent directory, so one above it. If you're looking at your current directory and you just see a slash, that means you're in the root directory. That means you're at the highest place that it can go. If you see a tilde and a slash, it means that you're in your home directory for your operating system. Root and home do have differences, and you'll see them. So can anyone tell me or take a guess what CD space ... does? Yeah. Good. Yeah. So CD ... goes to your parent directory. It goes one above the directory that you're currently in. And getting used to making this command will be really helpful, because it's honestly what you'll be doing most frequently compared to any other command that you're going to run. You're going to want to be going into directories, out of directories, stuff like that. Moving on to environment variables. Environment variables are strings that are available to your certain process and its children. So for example, a process would be your current shell session, your current terminal that's open. That's considered a process. Once you get into operating systems or learning on your own, you'll learn that processes are very complex, and something simple as just having a window open is running a process. So for example, if you want to create an environment variable, you just give it a name. And then, for example, if you want to make it a string, you just set it equal to the string hello world. And that environment variable is going to stay there until you change processes or you change its value. So of course, you can't really see it, but if you know that it's there, or if you have a file that lists all your current environment variables, then you can simply do echo with the $sign and the name of the environment variable, and then it will print what is inside of that variable. Next up, you'll notice that echo is a pretty cool command for quick printing to the command line, quick printing to your output. And this is also used with piping. So piping is sending information to and from a program or a process with the little less than or little greater than symbol. So here, echo, this outputs in the command line, that just puts it in the command line. It doesn't save it to an environment variable. It just prints it like directly after you write echo. Next, below that, echo with that string, if you pipe it into the file, it'll also print it to the command line, but it will put it into the file that you just created. So instead of having to do touch file 1, echo this pipe into file 1, if you do that, it'll create the file for you all in one go. So with piping comes actual sending, like the actual use of sending information in a network. Very familiarly, you'll be using SSH, which is a secure remote access to a machine over a network. I'm sure if you're in programming 1, programming 2, I'm not sure if they still have a lab, but they'll have you SSH into the CISE servers with Thunder, I think. I'm not sure if you guys are there yet. It's definitely the second week. But SSH, if you know the credentials to an existing account on that network, you'll be able to SSH into it from a machine that's not that machine. So you can't really send things over in SSH, but you can log into it and find out how to send things from there or to there once you're there. Next up is SCP. This stands for a secure copy, and it's pretty old. Now we have SFTP that has better features, it's newer, and it's somewhat safer, but SCP in general is a secure file transfer between computers over a network. So if you have a machine that you want to SSH into and you want to use that environment, but you have a file on your home machine, if you SFTP or if you SCP a file to that destination, it'll be as if you're just like Control C and Control V onto that machine. So instead of like sending an email or putting it on a flash drive, if you use SSH or if you use SCP or SFTP, the file transfer will be there. So coming with files, after you sent it, what if you don't know where it went? Or what if you don't know the specific directory that it went in regards to your home directory or the root directory? When finding files, you're going to want to use the find command, and the find command has a number of arguments and various inputs into it. It's a very, very good command. But here, if you want to find a simple file .txt, you're going to use find tac name, and then you put the file name. If you know the directory and you want to find all files with the same extension, you're going to do find with the name of the directory and use the same name argument and do star.txt. Star.txt is a sort of regex, which is a regular expression that you'll learn about soon. But star basically says everything that matches this file extension, we want to find it. And so what if you have a phrase that you want to search for within files? So you might not know the file name, but you want to find every single file that has a certain keyword in it. This comes in the grep command. So the grep command, you'll find it very, very useful as well. It can also be very complex, but with grep, if you want to find a specific keyword in file.txt, you're going to say grep keyword file.txt, and I'll tell you the exact line number that it's on. If you want to do grep tac-c with the word hello in file2.txt, it's going to count how many times hello appears in that text file. So the grep command is sort of like Control F, but it has a lot more functionality. So the rest of these commands that I told you about are only, I would say, like 1% of the available commands in Linux. Everything else you'll find through man pages. Man pages are going to be your very best friend because it's pretty impossible and pretty unrealistic to ask you to memorize every single argument for a command, every single command, what groups of commands that you can use in a pipe and stuff like that. So if you just look up, for example, grep man page on the internet, it will tell you what the command does. It'll tell you every single argument that it can accept in combination or just by themselves. And it'll also tell you what every single argument does. So for example, this is the man page for grep. Let's see if I can hide these meeting controls. Okay. So for example, this is the man page for grep. It will tell you that it prints lines that match patterns. It searches for patterns in a file, and it'll tell you every single pattern syntax that you can use for it. This is only like one little clip of it. Sometimes man pages can be pages and pages long because they're meant to be very detailed. They're meant to be sort of a Wikipedia for every single command that you can have in the Linux command line. So let's get started. I know that Aiden brought up Over the Wire Bandit in the red team meeting, but we want to make sure that you guys can actually dive into it and practice a lot of these commands that I talked about. So if you go to this link or just search up Over the Wire Bandit and start at level 1, you'll get a great firsthand look at various war games and actually learning how to use the command line. And it's a really great website because it tells you what commands you may use in which level, and tells you exactly how to get into the level. And first up, like the first step is actually SSHing into their server. So you'll get your first glance at using SSH. And yeah, so go ahead. A lot of us will be walking around trying to help you out with the various levels. but we'll see who can get to the highest level by the end of the meeting. Okay, so as you guys are doing your war games on Bandit, I just wanted to promo a talk that Jack Polk gave last year. Jack Polk was our webmaster. Last year, he gave a really large version of this talk, and he set up an actual server on the CISA machines to be able to go through these exercises. But because that server is no longer in service, you can't complete those exercises in real time. But if you have a virtual machine like we set up today, then you'll be able to do a lot of them and just practice traversing file systems and stuff like that. So if you're interested in watching his talk from last year, you can visit this YouTube link. Again, I posted all these links in the Discord. And if you are pretty far through Bandit and you want to try something else, this website called Linux Journey splits up topics to cater to beginner, intermediate, and expert sort of levels. They also have just quizzes instead of being like, okay, this is a command, run it. They have various quizzes for you to be able to test your knowledge on it. Of course, they don't count for anything, but it's always good to test yourself and see what you know so far. And then they also provide examples for you to try on your own command line. So Linux Journey is a great resource for that as well. Okay, guys, so I'm sure you guys are still gonna want to keep working on your exercises, and we're definitely not stopping you. We have this room probably until around 7:30. But I just wanted to make some announcements for next week. As usual, red team will be on Monday, blue team will be on Tuesday, CTF team will be on Wednesday. And I think they'll all be more or less in 312 around 6:30 p.m. Get the details specifically when our secretary makes our announcements. And next week, we have a tentative guest speaker from Emerging Tech. Emphasis on the tentative. We'll give you a for sure answer probably by the end of this week or early next week. But yeah, thanks for coming. I really appreciate you guys hanging in there with this pretty intro talk. Feel free to DM any of us. Make sure you join our Discord and make sure to follow us on Twitter. Yeah. Yeah.
Hello. So emerging tech tentative is slightly less tentative now. Also, they said they're going to be bringing pub subs and like chicken nuggets and things. So free food, good food, and cool startup potentially. Still not 100%, but most likely they will be here. So you should too.
Thanks, guys.